Today we are going to see about grid interactive solar PV based water pumping using BLDC motor drive. This system consists of PV array and BLDC motor drive and then grid as well as grid inverter. That means here we are using single phase grid. Here we have that PV, that single PV generating around 213.75 watts. 7 panel is connected in series. So it can generate maximum power of around 1496.25 watts at voltage of 199.5 volt, and it have current rating at a standard condition is 7.5 amps. Next it going to be connected to the DC link. So this is a DC link via this boost converter. This boost converter is considered as a power extracted along with the MPPT. So it going to be boost the voltage from 199 to 270 volts. Here we are going to maintain the DC link voltage is 270 volt. At standard condition PV voltage is around 200 volt. So that will be stepped up to 270 volt, and then the maximum power of PV will be extracted by means of this MPPT. This INC MPPT will be change the controlling pulse for this boost converter. So it going to receive two input. One is PV voltage and PV current. Based upon this PV voltage and PV current, so the incremental conductance MPPT will be generate the optimal duty cycle. So this optimal duty cycle going to be processed via PWM generator. So this PWM generator will be generate the switching pulse. The switching pulse going to be control this IGBT of that boost converter in order to extract the maximum power from the PV as well as boost the voltage from 200 to 270. The next process here we are using grid. The grid voltage here we are using 180 volt RMS, and then this is filter. This is source inductance, and this is LC filter, and this is single phase inverter that going to be connected to the common DC link. This inverter going to be controlled by means of two control method, voltage control and current control. That means here we are measuring the DC link voltage, and it going to be compared with the reference voltage, and it going to be processed via PI controller. So this will be act as a voltage controller. It will be generate the reference current magnitude. So this reference current magnitude going to be multiplied with the, that means by using source voltage we are generating omega t. Based upon omega t we are generating the sine wave. That means we are generating the unit vector. So this unit vector going to be multiplied with this reference current magnitude. Then we are getting the sinusoidal reference current. So here we are having sinusoidal reference current. So the sinusoidal reference current going to be compared with the actual source current, and again it going to be processed via PI controller. So this PI controller will be generate the modulating signal. So this modulating signal going to be processed via sinusoidal PWM. So this will be generate the switching pulse for this inverter to maintain the DC link voltage 270, and also based upon power balance. For example, this water pump will be act as a load. So if any excess power in the PV, that will be sent to the grid. If power of PV is less than that load power, then grid will be supplying the power. This is the concept. First we are going to test the model. I am going to fix water pump rating is 1000. That means this is around 1000 watts. Here you see we have that voltage source inverter and BLDC motor. Here we are taking the Hall sensor output. The Hall sensor output will be converted into back EMF by using this truth table. After the back EMF will be converted into getting pulse by using this truth table. So finally we are getting the 6 pulses. That pulses will be used to control this voltage source inverter in order to control this BLDC motor. Here I am going to take step change in irradiation. First I am going to take step change in irradiation from 1000 to 500, 1000 to 300, and then you have to check the result. This will be happen after 1 second. Here we can see the PV detail, and here we can see the source, grid, voltage and current, and here this current and back EMF of BLDC motor, speed and torque, and then here you can see the DC link voltage. Will open that all scope. Now I am going to simulate this model. Initially the PV irradiation will be fixed at to 1000 watts per meter square. Then it will be generated around 1500, nearer to 1500 watts. Load will be around 1000. What will be happen? Water power generating from the PV, that will be used to drive that load BLDC motor water pump. Then the excess power will be sent to the grid point. Here you see that the DC voltage stabilized at 270. The PV is generating around 1500 RPM. The excess power is sent to the grid now. So this is speed of the BLDC motor, torque of the BLDC motor. So this is stator current and the back EMF. We can zoom this stator current. We will see this. This is a stator current back EMF. Now you see that, right, the PV power reduced to around 500. So because of change in irradiation. Irradiation we are changing from 1000 to 300. Because of changing from 1000 to 300, the PV power comes to below, that means is around 500 watts. During that condition, so there will be changes in the DC link voltage. After some time it will be maintained constant. Now the source will be supplying power. So you will see that the direction, so both source voltage and current having 180-degree phase shift. So if it is both are having 180-degree phase shift, then the grid will be supplying power to the load. So this is the first mode of operation. So next you go with the second mode of operation. In second case, I am going to do another condition. That means I am going to disconnect this water pumping. For that, here I am going to change the load torque from 3 to 0, and also I am going to disconnect the water pump at the time of 1 second. So at the time of 1 second, I am going to change the load torque from 3 to 0, as well as I am going to disconnect this whole setup. So now we have to check the results, and also here I am going to make irradiation will be 1000, and then you have to check the results. For 1000 watts per meter square, PV generating around 1500 watts. Some power used for drive the BLDC motor water pump, and excess power will be used for, that means sending power to the grid. Here you will see that, right, the phase angle will be both are having 0. That means so it receiving the power. Now you see that because of BLDC motor disconnection, the load torque will be goes to 0, the stator current goes to 0, and then it has some disturbance during that time. After some time it will be comes to 270 volt. Now we can see that the current to the grid will be increased. That means is around 11 or 12 amps. This comes around 12 amps. That means whatever power we are generating from the PV, that will be sent to the grid. Because of disconnection of this load, that means BLDC motor water pump from the system. This is case 2 condition. Next condition, I am going to have another condition, same as it is before. So here I am going to make changes in the irradiation. Here I am going to make irradiation to 700. So I am going to make the irradiation 700 and 300. So here I am going to make 700. So 700, and here I am going to make 300, or I am going to make 100. Now what happened? PV now we are generating around 1000 watts. That will be only useful to supply this BLDC motor. Now we can see the result. Grid never receiving the power during this condition. So I will explain that things. This is case 3. Now you see that red current will be almost nearer to 0. It's not receiving power. Whatever power generating from the PV, that will be fully utilized with the water pump. Now what happened? The PV power goes to around 100. Now that grid will be start supplying the power. During that time it has some oscillation. After some time it going to be settled. So this is a case 3 condition. Now that means when the PV power is equals to BLDC motor, source never getting any excess power, so that current almost 0. When that PV is disconnected from the system, that means it's almost goes to 100 watts, then grid supplying the power. This is a case 3 condition. These are the case we can see in this grid interactive solar PV water pumping using BLDC motor. Thank you.